Well, hello and welcome to our No-Till Tuesdays webinar. This is our second in our series of 4 webinars we are offering on reduced tillage systems, primarily for use in silage corn acreage. My name is Deb Haliba and I work at the University of Vermont Extension Northwest Crops and Soils program, and I'm helping shepherd us through this series. So before we get started, I wanted to give a few housekeeping notes. First, we are very grateful to the Northeast Extension Risk Management Education Center that has provided funding support for the series. So I'm going to turn it right over to John. Dr. John Tooker is an entomologist at the Pennsylvania State University, where he conducts research and education programs, focusing on the relationships among plants, insects, and their natural enemies to provide and improve on integrated pest management strategies. And with that, John, I'll turn the mic right over to you.
Okay, Deb, thank you very much, and good morning all. So the organizers of the webinar asked me to talk about pest management and reduced tillage production. And that glorious animal you see on your screen is a jumping spider, and that is not colorized or anything like that. His fangs are actually, or her fangs are actually that color. And it's just a pretty little animal and is related to what I'm talking about, because I am convinced that beneficial arthropods, insects, and spiders together can be part of our pest management approach, and I'll talk about that a bit today. Okay, so this is a no-till webinar series, and I see great value in no-till for many reasons. I'm not alone in this, of course. It's been well documented that no-till agriculture decreases labor and helps conserve water and soil resources. And there are lots of other reasons to do no-till also. In Pennsylvania, we are predominantly a no-till state, and about 70% of our large acreage crops are in no-till. And the main reason for that is to help protect the health of the Chesapeake Bay. So by doing no-till, we expect to have less soil erosion, less nutrient runoff, less pesticide runoff into the Chesapeake Bay, and that will allow the Chesapeake Bay health to improve with time, because there'll be reduced sedimentation and all that stuff that accompanies it. But a question I often get, particularly from growers or agricultural professionals that aren't as familiar with no-till, is, does moving to no-till make pests more problematic? So these are insect pests, of course. And the answer is simply no, but it is the case that the suite of pests that challenge no-till growers is a little bit different. And there are generally 5 pests that I think about when it comes to no-till production, and 4 of them are listed here. They are black cutworm, true armyworm, stalk borer, and wireworm. But none of these animals is a perennial pest. They all just show up occasionally. And that stalk borer is actually one I've never seen with my own 2 eyes, but apparently it is a problematic in some no-till system somewhere. So it's not a huge concern. But the other 3 are occasional problems that kind of show up. The pest that is more problematic is the 5th that's not listed there, but it is shown in this picture. And these are slugs. So this is a fairly dramatic picture if you understand what you're looking at. It is the image of the front side of a hay mower after that hay mower went through a mixed grass alfalfa field at 9 o'clock at night on, I think it was May 12th, 2012. And those are all slugs across the front of that machine, emphasizing that in Pennsylvania, where no-till is very popular, it's kind of dominant, slug populations can be very significant. And recognize that slugs are not insects, right? So as an entomologist, I usually study insects, but this animal is a mollusk, more closely related to snails than anything else. They're really snails without shells, but their next closest relatives are bivalves, or like clams and mussels and that type of thing. And this will become relevant as we go through the talk. And I'll raise that issue occasionally. But what I hope to do today is just focus on slugs as a sort of case study, because in no-till production, slugs are some of the most some of the most challenging things to control. And it's my perspective that if you can control your slugs, then the other pests are kind of a piece of cake. So I don't expect that folks in Vermont and other parts of New England to get slugs right away. But again, it's a perspective that it's a bad thing to have. And if you can solve this with the approach that I've taken, I think the other ones will fall, other pest species will fall in line. So just a little background on slugs. They can damage virtually any crop species that's planted in Pennsylvania. More and more folks are growing canola, and they're seeing that slugs like canola very, very much. It's kind of like candy to them. They also enjoy soybeans, alfalfa, and small grains, and they'll feed heavily on corn. But actually corn is a poor host for them, and as I'll get into in a little bit, if we can give them something to eat other than corn, they'll usually take the option. By a University of Delaware estimate, about 20% of no-till acreage in the mid-Atlantic states suffers from yield loss from slugs annually. And that's about 600,000 acres, so it has turned into kind of a perennial problem down here. And it seems to be getting worse. That's at least what most growers tell me, is that 20 years ago they didn't have slug problems, but now they do, so they think something has changed. And slug damage in corn and soybeans is fairly distinctive. Up here in the upper left-hand corner is a small gray garden slug feeding on a soybean cotyledon, and that pitting damage is slug damage, and this stem next door has no cotyledons, so that one will probably die. And the picture below that is a soybean field, about a 30-40 acre field that has whole hillside kind of removed of soybeans. And corn damage is a little bit different. It causes this type of striping or stripping damage, shredding damage, I guess, and it can be very, very easy to identify. But in cornfields, you tend to get these patches of damage where the residue is particularly thick or the field lies wet. So I said earlier that there are benefits of no-till beyond labor, conserving water, and soil, and one of them is the stability that no-till provides. That's a very good habitat for natural enemies. So in this field that's thick with residue, one might look at that as just a potential pest problem, but I see it as habitat. And so a lot of good things will hang out in that habitat. You might first think of earthworms, but a lot of good natural enemies will also hang out there, and they can be allies in pest control. If you put cover crops on top of that no-till system, then you get even more good insects and spiders, and they can help kind of build this food web, and that food web provides a more immediate control if pests show up. So I am a strong advocate for diversity, and the more diversity we can have in fields and in cropping systems, the better, because the more connections between different trophic levels can help with pest control. In such situations, animals like this can be fairly common. So these are ground beetles. The upper left-hand corner shows the larval form of a ground beetle, and then the lower right-hand corner shows the adult. And these are great animals to have around, and if we farm properly, we can foster good populations of these guys, and they can be allies in pest control. And one reason that ground beetles are so good is because both the larval stage, this worm-like looking thing, and the adult are predaceous. So the larva is subterranean. It burrows through soil trying to find food, and anytime it runs across an insect down there, it'll eat it. And the adult runs around the top of the soil doing the same thing. So they can be very good at what they do. And if you can have a maximized population of these guys, they'll help with pest control a great deal. And fortunately, they'll eat many of the pests, or all the pests that are problematic, tend to be problematic in no-till. So black cutworm, true armworm, stalkborer, wireworm, and slugs are a regular part of these guys' diets. So again, maximizing these guys will allow us to use less insecticide and rely on inputs less when it comes to pest control. Now here's a video, and it simply shows a ground beetle attacking a corn earworm. And this is a bit artificial because corn earworms are typically up on plants, but it just emphasizes that when these two encounter each other, the only winner is going to be the ground beetle. Okay, so that caterpillar is more or less sitting duck, and the lion is going to rip into its prey and start eating it. So now the guts of the caterpillar are outside it, and the ground beetle is kind of enjoying it. But it just emphasizes kind of the power of these guys in a short video, that if there is an encounter, the ground beetle can win. So you can imagine if you have a couple thousand of these guys, a couple tens of thousands of these guys running around a crop field, that they're going to be your allies in pest control. This is a figure that we generated in our research a while ago, and it's kind of ugly, but I keep it around because it is the first sign that we had that if we have slug populations, these type of ground beetles, also called carabid beetles, there's that word there, so scientists will call these guys carabid beetles or ground beetles. So there's a negative relationship here between slugs and ground beetles. The black dots show data from alfalfa, the red dots show data from corn, and what we have here on the y-axis is the number of slugs per shingle. To sample slug populations, we put cut up pieces of rolled roofing in the field, so it's actually white shingles, and then slugs will just gather under there as an artificial shelter, and we can go out and count them. The x-axis is the number of ground beetles per pitfall trap, and a pitfall trap is just a cup that we sink into the soil, and then these ground beetles kind of bumble into that, and we can capture them and go out there and count them. So in both crops, alfalfa and corn, where we find a lot of ground beetles, we find very few slugs. And where we find a lot of slugs, we find very few ground beetles. So a lot of slugs, very few ground beetles if you come down to the horizontal axis. So there's this negative relationship between ground beetles and slugs. So if you can foster better ground beetle populations, your slugs should go away. And that would also be the case for other pests in your field, whether it be black cutworm or armyworm or wireworm. So this relationship should maintain, but our data are strongest when it comes to slugs because that's been our focal species for a couple years now. Okay, let me switch gears here and talk about insecticides. So I see insecticides as valuable tools, but they are overused, whether we're talking about soil-applied insecticides, foliar-applied insecticides, or the insecticides are now coated on the majority of corn and soybeans in the country. They all tend to be overused. But I see them as valuable tools when used appropriately, and that would be in an integrated pest management framework. So that's what IPM is. So I advocate for insecticide use only in this integrated pest management framework, which means that if we're going to use insecticides, there should be a strong justification to do so, and that justification needs to be more than just making a farmer more comfortable or sleeping better at night. Okay, so I want economics to drive the decision, not just the whims of particular people. And if we don't use insecticides well, if we don't use these tools appropriately, there are unintended consequences. The first unintended consequence that we've documented pretty well is that the insecticides decrease the number of good things in your fields, whether it be spiders or insects, and that can lead to worse pest populations. And secondarily, there are environmental concerns, not the least of which is water pollution associated from insecticide runoff from fields. I'm not going to go into the environmental concerns, but they're out there, and if you don't know about that, I just encourage you to look into that. Particularly, you could Google neonicotinoid insecticide and water pollution, and a lot of information will come up. But I want to emphasize that all insecticides in my eyes are the same, whether they're applied to leaves, they're applied to the soil, or they're coated on seeds. Our research shows that these insecticides are negatively influencing good insect populations similarly, despite what people might think about an insecticide just being applied to a seed and being restricted there. That's not what we see. We see some broader influence of these guys. And this is evidence of that. So this figure shows the influence of neonicotinoid seed treatments on slug populations. So on the y-axis here we have the number of slugs per trap. Again, those are shingle traps. And over the x-axis is the corn growing season. The red line shows the average number of slugs that we found in corn plots where the corn was grown from seeds treated with a neonicotinoid insecticide. In this case, the insecticide was clothianidin, whose trade name is Poncho. So in this case, Poncho was coated on the seed. And the blue line shows the average number of slugs where we weren't using Poncho as a seed coating. That actually was a naked seed. You can see over the course of the growing season, on average, we have more slugs where we're using the insecticide than where we're not. And that, of course, is not what the farmer wants to happen. that this is a case of the insecticide taking out the good insects. I'll show you a little more data now, and those data come from this experiment that we conducted in 2012, where we had 12 plots. Half of them were treated with Cruiser Max, and the others remained untreated. The Cruiser Max treatment included thimethoxam, which is another neonicotinoid insecticide, and a couple fungicides. But the fungicides are not part of this story. You'll just have to take my word for it for the time being. This is an insecticide-driven story. And the plots were bigger than average research plots. They were about a quarter acre apiece, and the soybeans were planted on 30-inch rows. And I'll walk you through 4 figures just to emphasize the results that we had. So here on the y-axis we have yield of soybeans, and the x-axis we have the number of soybean plants per acre. Not surprisingly, as soybean plants per acre goes up, yield goes up, but notice the color of the dots. Where we have no insecticide, that is the white dots, the open circles, we have more soybean plants per acre and we have greater yield. The next figure shows soybean plants per acre on the vertical axis, and then number of slugs per trap on the x-axis. As the number of slugs per trap goes up, the number of soybean plants per acre comes down, and then of course the yield would come down. But again, the color of the dots matter. Where we have the black circles, or where we had the insecticide coated on the corn seeds, or sorry, the soybean seeds, we have more slugs per trap on average, and we have fewer soybean plants per acre. This figure brings those predators into play. So that's a picture of a different type of ground beetle, but it's still a ground beetle. On the vertical axis here we have predation. And with predation, the larger the number, the better. So this is really the proportion killed. To get this number, what we do is we take waxworm caterpillars, we put a pin through them, and we put that pin into the ground, and then we come back and we check on that caterpillar every once in a while to see what's eating it. So this is a measure of predation. The more those caterpillars that disappear, the stronger the predator population in those fields. Then on the x-axis, we have slug predators. And this is again those pitfall traps. So as the number of slug predators increases, predation, not surprisingly, also increases. But again, the color of the dots matters. On average, where we don't have the insecticides, the white circles, we have more slug predators and more predation. And here's the final figure that I'll share with you. And this is the number of slugs per trap on the y-axis. So again, those are our shingle traps, and here's my technician Andrew checking a shingle trap. And then again, the x-axis is predation. So that's the same number that was on the vertical axis. Here is now over in this right-hand figure on the x-axis. So as predation goes up, the number of slugs per trap comes down. But again, the color of the dots matters. So where we have the insecticide in the black dots, we tend to get less predation and have more slugs per trap. So what's happening here is that insecticide coated on the seeds is actually disrupting biological control. So those natural enemies in the fields, those predators and potentially some spiders, would be feeding on slugs if their populations were stronger, but the insecticide coated on the seed is actually limiting their population. By limiting the population of predators, that releases the slugs from biological control and causes them to be more problematic. So this little story emphasizes to me that farmers need to manage for the pests that they have. Rather than blindly using insecticides where they may not be useful, let's deploy insecticides where we know they can be helpful. So remember that slugs are mollusks. There's no reason to believe that an insecticide should control a mollusk. In fact, our data show the opposite. Insecticides can make mollusk problems worse because the insecticides kills the insect that should be able to help with mollusk control. So if we had more ground beetles out there, then the slug population would be lower, but the insecticides taking out the ground beetles, allowing the mollusks to succeed. So I tell growers, use the insecticides you need, but no more. And to do that, you use IPM. Our research isn't the first example or the first evidence that this is a valuable approach. There's other research that's happened. This is a particular study from the University of Delaware that came out a couple years ago now that emphasized that the stability and diversity provided by a no-till system gives predators a chance to be effective. In this case, These researchers had 4 different treatments in a 6-year study that a continuous corn rotation, I guess that's not a rotation, but a continuous corn production system where they applied preventative insecticides, then a corn-soy rotation, a corn-soy-wheat rotation, and a corn-soy-wheat rotation with cover crops. And this final one, that's where they implemented IPM. So they scouted, they looked for pest populations. If pest populations exceeded an economic threshold, then they applied an insecticide. And not too surprisingly, they had their worst pest populations in that continuous corn with preventative insecticides. And they had their least pest problems in the more complex rotations with cover crops where they're implementing IPM. Kind of exactly what you would expect. We're just deploying insecticides where we need them, and the less we use them, the less we rely on them. We've had a project here at Penn State for about 6 years now called Penn State's Diversified Dairy Cropping Systems Project. And we've been comparing 2 types of rotation. One is a very simple corn-soy rotation, and we've been comparing that to 2 6-year rotations that are far more complex. They usually have corn silage, they usually have soybeans and some small grains. They also include alfalfa and small grains. And these 2 types of rotations have 2 different pest management approaches. In the simple corn-soy rotation, we're using Bt corn. We're using insecticidal seed treatments on the corn and the soy, and we're also putting a broadcast pyrethroid near the time of planting as a preventative approach to control pests that might show up. These are tactics that farmers generally use. And then 2 6-year rotations, we're using IPM. That is, we're not using Bt seed, we're not using insecticidal applications to the seed, we're not using fungicides applied to the seeds, and we're scouting all the plots and we're applying insecticides as necessary. And similar to the previous example, where we see the most pests are in this more simplified rotation where we're using these preventative approaches to insect pest management. In fact, in this experiment, slugs have been the worst problem, and our slugs are far worse where we have this 2-year corn-soybean rotation with the preventative pest management options compared to the more complex rotations with IPM. So we know that insecticides can disrupt biocontrol, so I encourage farmers to scrutinize and then optimize their insecticide use by using soil insecticide, broadcast insecticides, and seed treatments only as necessary and not using them blindly. So that would mean to me that integrated pest management is then being used. So we're using that to protect our allies, and to use integrated pest management, we scout fields, we apply known economic thresholds to the situation, and if the population of pests exceeds that economic threshold, we use insecticides when it makes economic sense. Okay, so I've kind of gone through the general kind of research and justification that has brought us to where we are today in our research, and I'll just go into a quick little story about a farmer who is using an IPM approach and has seen great results with it. So this is Lucas Criswell, who I know has been up to UVM to talk at your no-till meeting that is held in February. And Lucas is on the left there in the blue shirt, and that's his father to the right. And they are long-term no-tillers in Union County, Pennsylvania. The closest big town you may have heard of is Lewisburg. And over near Lewisburg, there's an odd slug problem, and I went over to Lucas's farm on the first times I met him, and we were looking at a field of barley that was slowly disappearing from slugs. And he made the observation that there's nothing else green in that field for slugs to feed upon if they want to feed upon something green. So like in this left-hand picture, you just have rows of crops, and there's nothing else besides the crop if a pest wants to feed upon something green. And if they do feed upon something green, this is what the corn ends up looking like. This is corn, but his problem was with barley. So standing there next to his field that day, we just hatched up a plan. We said, what if we give the slugs something else to eat? And this is what we did. So we asked the question is, can intercropping improve slug control? So what we did is we planted rye between rows of soybeans and rows of corn. This picture shows the soybean, but this is research that was done at our Penn State Research Farm and then about 50 miles to the east on Lucas's farm near Lewisburg, Pennsylvania. This picture shows a line of rye, that's cereal rye, and there's a line of soy, cereal rye, soy. And that cereal rye was the seed was put into our fertilizer box of our corn planter, and then we went across the field, so we actually established 2 crops at once. Over to the left here, you can see a similar plot that doesn't have the rye between the soybean rows. So we did this as a way to provide an alternative food for slugs and a way to distract them. And these data show that we did indeed distract them. So on the y-axis here we have slug rating. We rate slug damage to corn and soybeans on a 0 to 4 scale, when a 0 is no damage and a 4 is a nearly dead plant. And this shows where we didn't have the rye between the rows and where we do have the rye between the rows. So we had significantly less slug damage to our cash crop when rye was between the row, in part because slugs seem to prefer to feed upon rye than they do on corn or soybeans. At the same time, this rye between the rows really increased our ground beetle population. So this figure shows the number of individual ground beetles that we captured in our traps, where we had no rye between the rows and where we had rye between the rows. So putting rye between the rows tripled the number of ground beetles that we tended to get. So this provided a nice little story and evidence that we have a 1-2 punch going on. If we can put something between the rows, we can distract slugs and increase the number of ground beetles. So Lucas took this information and ran with it far quicker than I was ready for him to run with it. So the first year he tried this, he started what we call planting green. So he started by planting into a standing green cover crop. In that experiment I just described, we established the cereal rye and the cash crop at the same time in the spring. But it doesn't take a genius to recognize that we are using cover crops, broadly speaking, in Pennsylvania and other parts of the world. So maybe we could just adopt that cover crop to improve our slug control. So in this picture we see cereal rye that Lucas established with a drill, but he closed up every 2 holes so there's a gap he could plant into. In the spring, he then planted his soybeans and his corn into that gap, as you can see in this picture. And it worked awfully well. So he saw virtually no damage to his corn or soy from slugs. So he went in whole hog, and then he started planting like this without leaving the gaps in his cover crop. In this, he saw clear soil health benefits because the soil is always covered. You're going to get reduced erosion. You're going to be increasing organic content. You're going to increase biodiversity. But if you're going to take this approach, a farmer needs to be committed to IPM because this needs to be scouted for black cutworm or true armyworm pretty regularly. Lucas went one step further, and rather than planting in that standing green rye, he started to roll down his rye. So this shows his planter as it is currently configured, and he has these rollers on each row unit. And when he goes through a field, it now looks like this. So he's planting and rolling his cereal rye all at the same time, and he sees clear benefits to putting the rye on the ground, including uniform cover, kind of better planting conditions, and then that biomass persists longer. That's what it looks like when you zoom in on it close up. And he sees clear benefits to production. He's getting about the same yield whether he uses a treated and traded corn like Acre Max or an untreated conventional variety of corn. He's getting equivalent yields, but he's decreasing his pesticide use by about $9,000 a year because he doesn't need insecticides anymore because this is habitat here and the good insects come. He's also reduced his herbicide bill because this thick thatch prevents weeds from coming up as abundantly as they did before. So he sees clear benefits in this system and is having good luck. And importantly, this thatch persists. On the right-hand side, this is the thatch that persists where he's rolled it into August, it's still evident, whereas in a plot where he didn't roll it, there's no thatch there at all. So the right-hand figure is providing habitat to these good insects, continued weed suppression, well into August, and less soil erosion. So I'm kind of at the end of my talk here. So my point in bringing Lucas's in is just an example of implementing IPM and valuing diversity to help with pest control. It is the case that no-till, diverse rotations, and cover crops can build natural enemy populations. If you're doing all these things to value soil health, a benefit of that is that natural enemy populations will come. But you can maximize the benefit of those natural enemies coming by scrutinizing your insecticide use. If you're valuing soil health and using insecticides blindly, then you're not valuing soil health as well as you could. I would encourage you to consider that and then try to control the pest populations only when necessary, and to do that you need IPM. So scouting to understand your local pest populations, applying economic thresholds, and using the insecticide only when it makes kind of economic sense. Final picture is just a pretty image of a assassin bug attacking a Japanese beetle, and I'll be happy to take any questions.
Well, John, thank you so much for joining us today. Really appreciate your time and expertise. And thank you all for joining us. I just wanted to give a reminder that, this is a series, obviously, and next week we've got University of Maine Cooperative Extension's John Jemison and Rick Hersbergen, who will be talking about managing no-till soils. So we hope that you'll join us next week as well. And until then, have a great week. Thanks again, John. Really appreciate it.
Thank you, Deb. Bye now.